Right now, while you're reading these words, something is happening less than 2,000 light years from here that almost nobody on Earth has ever heard of. A star almost identical to our own sun is being pulled through a slow, silent orbit around something that gives off no light, no heat, and no signal that any instrument on Earth could ever see directly. Here is the part that should unsettle you. The universe doesn't hide its monsters. It just doesn't bother announcing them. It is not a dead star. It is not a planet too dark to reflect light. It has been sitting there since before the pyramids were built, before humans had a word for star, before anyone on this planet had any reason to look. And until 3 years ago, nobody knew it was there at all. If something this close can go unnoticed for that long, the real question isn't what else is hiding out there. It's what else is hiding this close. Astronomers gave it a catalog name instead of a proper one, Gaia BH1. But look past the label and you find something almost tender, an ordinary G-type star, the same spectral class as our own Sunday, same size, near enough. Same temperature, near enough. The same pale yellow-white light that, if you stood on a world orbiting it, would rise every morning and feel like home. For most of its life, this star has done exactly what stars are supposed to do. Burn quietly, warm whatever worlds might circle it. Ask nothing, threaten nothing. It is the most unremarkable object in this part of the sky, right up until you ask what it's orbiting. In 2022, a spacecraft named Gaia, Europe's billion-star cartographer, built to measure the position of nearly 2 billion points of light, with a precision usually reserved for surveying the ground beneath your feet. Notice something wrong with this ordinary star's motion. It wasn't moving in a straight line. It was wobbling, dancing, almost tugged, ever so slightly, off its expected path, the way a partner leans without you ever seeing who's leading. Something was pulling it. Something with the gravity of nearly 10 suns. And that something gave off nothing. No glow. No flare. No X-rays bleeding into space the way a feeding black hole usually screams its presence to the universe. Whatever was out there wasn't announcing itself. It was hiding in plain sight, disguised as empty space. And it had been hiding, undetected, since long before Gaia ever existed to notice it dancing. Here is the strange part nobody talks about. Even though the black hole itself gives off nothing, it doesn't leave the space around it untouched. Gravity that's strong doesn't just pull matter, it bends light itself, warping the space behind it into a smear of borrowed starlight, curved into a ring around something that isn't there. If you could somehow get close enough to see it, not just its shadow, but the light twisting around its edge, you would be looking at the sky folded back on itself. Stars behind it, doubled. Stars beside it, stretched into arcs they were never meant to make. It would look less like darkness and more like a wound in the picture of the universe, one that light itself can't quite close. This is what scientists call a dormant black hole, and the word dormant is doing a lot of quiet work in that sentence. It does not mean small. It does not mean safe. It means only that, right now, nothing is falling into it. No gas, no dust, no unlucky debris lighting up on its way down. A feeding black hole betrays itself. The infalling matter shrieks in X-rays as it dies. A dormant one says nothing at all. If you could stand at a safe distance and look directly at Gaia BH1, you would see exactly nothing. No shadow darker than the space around it. No shimmer, no distortion, no warning sign. Just a normal-looking star, alone, apparently orbiting nothing, because the thing it orbits refuses to be seen. Every dormant black hole in this galaxy is doing the same thing right now. Sitting in the dark, saying nothing, waiting to be noticed by nothing more than the faint mathematics of a wobble. Put numbers to it, and the strangeness gets sharper. The star, 0.93 times the mass of our sun, 99% of its width. A surface temperature within a few hundred degrees of the one keeping you alive right now. The black hole, nearly 10 times heavier. All of that mass compressed into a point smaller than a city, wrapped in an event horizon you could drive across in under a minute, if driving were even possible there. They circle each other once every 185 days, a wider orbit than the one Earth traces around the Sun, and yet close enough, in cosmic terms, that the two of them are effectively neighbors, sharing the same small patch of space for longer than human civilization has existed. Nobody has ever fallen into Gaia BH1. Nobody ever will, on purpose. But the physics is well understood enough to describe it, and the description is not comforting. Close enough to the black hole, its gravity would no longer pull you as one piece. It would pull your feet harder than your head, stretching you the way taffy stretches under its own weight, thinner and thinner, until the difference between you and not you stops meaning anything at all. Astronomers have a term for it, almost gentle in how clinical it sounds: spaghettification. A word invented so scientists wouldn't have to describe, out loud, what actually happens to a body torn apart one atom's difference in gravity at a time. And somewhere past that point, nobody knows exactly where, is the event horizon, the line after which nothing, not light, not information, not the fact that you ever existed, comes back out. But here is the part that should not be possible. Black holes like this one are born violently, from stars dozens of times heavier than our Sun, stars that live fast and die in catastrophic collapse, shedding their outer layers in one final act before what's left crushes down into something with no surface at all. A star that massive, before it dies, doesn't stay small. It swells. Some of these dying giants balloon out to a size that would swallow everything in an orbit as close as the one this Sun-like star currently holds. Which means, according to the physics we trust everywhere else in the universe, this ordinary, sunlight-colored star should have been swallowed whole, long before the black hole it orbits ever finished forming. It should not exist. It should never have survived to see the black hole it now quietly circles. And yet it's there, orbiting, undisturbed, as if nothing happened at all. Gaia BH1 would not be the first false alarm. Twice before, astronomers announced they'd found a black hole this close, this ordinary-looking, and twice, the claim fell apart. A system called LB-1 made headlines as a monster black hole hiding in plain sight, until further observations showed the signal could be explained by something far less exotic, the star itself, misread. Another called HR 6819 met the same fate a year later. Both retracted, quietly, the way most failed discoveries are. What makes Gaia BH1 different is almost boring, and that's exactly the point. No assumption about the star's mass had to be stretched to make the numbers work. No convenient tilt of the orbit was required to hide anything, and there's no sign of one star feeding on the other to explain away the signal. It survived the scrutiny that killed the others. That, as much as the discovery itself, is why astronomers trust it. Astronomers have proposed two ways this could have happened, and neither one is fully settled. One idea, the dying giant, in its final years, might have thrown off so much of its own mass in violent stellar winds that it simply never grew large enough to reach its companion at all, shrinking instead of swelling, right at the critical moment. The other, the smaller star, was engulfed anyway, dragged into the outer envelope of its dying companion, spiraling through a shared atmosphere thousands of times hotter than anything it was built to survive, and somehow spiraled its way back out before the end, ejecting the very material that should have killed it. Both explanations are plausible. Neither has been proven. Somewhere in that unresolved gap sits the true story of how a star that looks exactly like ours survived an event that, by every model we have, should have erased it completely. This isn't the first time humanity has gone looking for something that hides by definition. In 1964, a rocket-mounted detector caught a flicker of X-rays from a system called Cygnus X-1, the first object anyone seriously proposed might be a black hole. It took almost a decade of argument before most scientists agreed. For nearly 60 years after that, every black hole we found was found the same way, by catching it in the act of feeding, watching matter scream on its way down. We only ever saw the loud ones. The quiet ones, the dormant ones, doing nothing, giving nothing away, stayed exactly where they'd always been. Invisible, uncounted, waiting for someone to stop looking for light and start looking for the absence of it. In all of human history, only 2 black holes have ever been photographed directly. In 2019, the Event Horizon Telescope, a network of radio dishes spanning the width of the Earth, all pointed at once, captured a blurred amber ring around the supermassive black hole at the center of the galaxy M87. 3 years later, the same collaboration managed the same trick on the black hole at the center of our own galaxy, Sagittarius A star. Both images took years of processing to produce. Both are burned into the public imagination now, the closest thing humanity has to a black hole's face. But notice what made them possible. Both were feeding. Both were surrounded by glowing, infalling material bright enough for a global telescope array to eventually catch. Gaia BH1 will never look like that. It isn't glowing. It isn't feeding. It will never have a face. Only a shadow it casts on the motion of a star beside it, which is, in its own way, a stranger kind of proof. This entire hunt, the whole idea of finding a black hole by watching a star dance instead of glow, is younger than most people watching this video. Gaia BH1 was not an isolated find. It was a proof of concept. Astronomers, once they knew what a wobble like this looked like, went looking for more, and within 2 years they had found 2, Gaia BH2, a black hole 9 times the sun's mass, hiding behind a giant star nearly 4,000 light-years away, and Gaia BH3, 33 times the mass of the sun, the heaviest stellar remnant black hole ever confirmed in this galaxy, hiding barely 2,000 light-years from where you are sitting right now. 3, in the space of 2 years. And the hunt hasn't slowed down. New diagnostic methods, refined just this year, are already sifting back through Gaia's full catalog, flagging more candidates, more quiet stars that might be dancing with something nobody has noticed yet. Found only because someone finally learned to look for the dance instead of the dancer. Astronomers estimate there are roughly 100 million black holes drifting through the Milky Way alone, roughly the population of a large country. Invisible, ownerless, walking among the stars the way you might walk through a crowd without knowing which strangers are which. As of this year, we have confirmed a small handful, which means, statistically, for every dormant black hole we have ever found, there are millions more out there right now, orbiting some other unremarkable, sunlight-colored star, tugging it gently off course, waiting for someone, someday, to notice the wobble. Somewhere out there, tonight, a star that looks like ours is orbiting something that isn't there. It doesn't know. It can't know. It simply falls, the way it has always fallen, the way it will keep falling long after every telescope built to notice it has gone silent. Maybe that's true closer to home too. Maybe something is out there right now, nearer than we think, dark enough that no instrument built by human hands has caught its wobble yet. Maybe it is patient. Maybe it has been patient for longer than our species has had a word for patience. Maybe it's closer than any of the others we've found. Maybe it has already changed the shape of a star's shadow somewhere in our own sky, and we simply haven't looked in the right way yet. We used to think the sky was full of light. It is mostly full of things that don't give off any at all. Out here, even silence has weight.